Okay, we didn't have a chance to start this in class, so I wanted to make sure you had information enough to be able to feel good about the homework. So our next set of skills is to be able to sketch a graph of a sinusoid if we're given its equation, and to go in reverse to write the equation of a sinusoid given its graph. And you'll practice both of those for homework tonight. First of all, a sinusoid is in the form y equals a sine b of x minus h plus k. In other words, it's just one of the, it's just a sine function that has undergone transformations a, b, h, and k. If this was a cosine b of x minus h plus k, we would still call it a sinusoid. So press pause and read through these this procedure, these steps for graphing a sinusoid, and then press play after you've read it. Okay, so we're going to walk through these steps for this example, which is actually the second one on this page. The reason we're going to start here is because there's actually a little thing you got to be careful of here in the form of the equation. So notice it's given y equals sine of quantity 2x minus pi plus 1. But if we go back up to the form of a sinusoid, we notice that the b value is actually factored out. So before we start in on the graphing, we have to make sure that our equation is in the form a sine parentheses b parentheses x minus h plus k. So we're going to have to factor this 2 out here to get it into that form. We call this pi here a poser h because it looks like it's the h shift, but it's not actually the h shift until after you've factored the 2 out. So of course, when you factor the 2 out of the pi, you're left with pi over 2. So using this rewritten equation, we're going to identify our a, b, h, and k shifts. So a is 1, b is 2, h is pi over 2 now because we factored out that 2, and k is the vertical shift here, the 1. Okay, so now that we know what a, b, h, and k are, we are going to sketch the midline. Now the midline of a parent sine function is usually the x-axis, right? However, this was shifted up 1, so the midline is now y equals 1. So I draw this dashed line first and label it y equals 1 as the midline. And then I use the value of the a to tell me the amplitude of the function. I know that from the midline, my function will go up to a maximum of 2 and down to a minimum of 0. So I label on the y-axis 0 and 2 as the minimum and maximum values of my graph. And then I determine the period and scale my axis to include quarter period intervals. So we recall that for sine and cosine functions, we can determine the period by doing 2 pi over b. Our b value is 2, so our period is pi. So I go over here and I do 8 tick marks because I'm supposed to draw 2 periods. And I'm really interested in the quarter period tick marks. So I label pi and 2 pi as good benchmarks for my x-axis. Now I plot the starting point, taking into account the h shift. So I know that my parent sine function has been moved to the right pi over 2 because my h value is pi over 2. I also know that my normal sine function starts at an intersection of the midline and increases. So what I'm going to do is I'm going to plot my first point at pi over 2 at the midline and increase. So I plotted this green dot there, and I know from here it's going to go up because the sine function increases first. And then every quarter period I'm going to put a max and then a midline and then a min, midline, max, midline. And then I can work backwards from this point, which was the first one I plotted. And a quarter period to the left of it, I would plot its minimum. And then a quarter period to the left of that, I would plot its midline. So I have all those key points plotted, and then I just connect the dots in a nice smooth curve, and that gives me my sinusoid y equals sine 2x minus pi plus 1.